All right, so in this lesson of properties of functions, functions have a lot of different qualities that we need to look at. And the first thing that most people would like to know is where are the x-intercepts. And I know y'all know what x-intercepts are, so that is not why I'm talking about this. This is just one of the things they ask us to talk about in relation to a function. Where it touches the x-axis is important. But students always get this wrong because they won't write it in point form. They just want to make me a list of x's, and that's not how you give x-intercepts. If you want to tell somebody an x-intercept, you got to give the point that's located there. For example, this is negative 10, 0. I can't say negative 10. I got to say negative 10, 0. It's a point. Where's the next one? Negative 5, 0. Somebody said 0, 0, right? I heard that. Where's another one? 5, 0. So it's easy to find them, but it's the proper format to write them like this. And students usually don't do that. All right. Now how about y-intercepts? Places it touches the y-axis. 0, 0 is the only one. 0, 0 is the only point that can be both. Why? That's where they intersect, right? It's the origin. It's the only place where the y and x-axis intersect, so it's the only place it can be both. All right. The third thing that we want to discuss is intervals. We're going to look for increasing intervals. We're going to look for decreasing intervals. And we're going to look for constant intervals. And as long as it's going up, we want to figure out the length of a whole entire segment for increasing till it starts to go back down. Or what would make it constant? A straight line. I don't have one of those in here. But that would mean like if it's horizontal. So, let's talk about increasing. Now, intervals is a type of notation. And I think you studied this in one of your math classes before, where you put brackets and parentheses for the two numbers on where it starts and where it ends. But because we're doing intervals of increasing, decreasing, and constants, we only put parentheses because we don't include the numbers. Because, for example, it decreased till it got to here, right? But is it decreasing on that point? No. It's only decreasing between those points. So from negative 10 down to negative 8, it's decreasing. Now, how did I know that I'm supposed to be using x's? It's because you describe all graphs based on x. You don't describe it based on y. You describe it based on x. So now, let's start doing it negative 8. And when does it stop increasing? Okay, so negative 8 to negative 2 is increasing. Now I'm up here at negative 2. What's it doing now? Till 0. So we're going negative 2 to 0 is decreasing. Now it's on to 2. No, the x value. Correct. From 0 up to 2 is the x value up there at 210. And now it's going to decrease again and be from 2 to 5. And now at 5 it's going to increase one last time from 5 to 10. This graph has no constant spots in it. But if it did, it would be something that looked like that would be a constant one. In case we have one later.
So you only use the x values when you're doing the increasing and decreasing?
Right. Because you want to talk about what is the function doing between these x values. And why you don't use the y values is the y values are actually doing the increasing and decreasing. Think about it. The y value here is 0. It went down to negative 4. Those are the numbers that are actually doing the increasing and decreasing. But you're telling what x values is that happening on. Okay? The next thing that we normally would do is say if this is an even, odd, or neither function. I'm running out of room here, so let me erase something. And I'll change it to a different color so we can not have it running into the right. So, on number 4 is the function even, odd, or neither. To be even, it has to have y-axis symmetry. To be odd, it has to have origin symmetry. Otherwise, it's going to be neither. Now, that doesn't mean it has x-axis symmetry if I say neither. It just means it's not symmetrical about anything. So, it definitely doesn't look like the two halves of the graph on each side of that y-axis are the same. It does not look like quadrant 1 would rotate to quadrant 3. It doesn't look like quadrant 4 would rotate to quadrant 2 or 2 to 4 because 4 is empty. So it's neither. Alright, so the last thing that we discuss is about maximums and minimums. And there's 2 different ways this information can be given to you. So I want to first give you the way you're used to, and then we're going to twist it a little bit and change the direction slightly, and you'll see it's just a slight bit different. Okay, so we call them local maximums and minimums. And the reason we call them local maximums and minimums is because there's so many of them in the same picture. Does that make sense? It's not like there's just one. There's lots of them. So they're local maximums or minimums. So every time the curve gets all the way to the bottom of the curve or all the way to the top of the curve, you have a local maximum or minimum. So that would be here. And when you change from increasing to decreasing or decreasing to increasing, which is a very important topic for calculus, which is why this is taught in this class, you know there's going to be a maximum or a minimum. So that's important to know because if you don't have the function itself to graph, and all you know is when it's increasing and decreasing, you know where your maxes and mins will happen. So, is this a max or a min? Alright, so I have a minimum at -8, -4. Alright, is this a max or a min? Well, I should have left more room here. -2, 6. Is this a max or a min? Min. And that one's kind of a weird one because it's kind of pointy. Does everybody see that's different from these? We call that a cusp in calculus. And it's usually caused by some kind of radical problem. And then this one here, max at 210. And then this one here, min, okay, which is at 50. All right. Now, no, because I don't know what it's doing. I don't know after that if it's going to turn back down or keep going up. So that's why you can't choose your ends because you don't know what it's going to do after that. You only know what it does in between here. So your maximums and your minimums are what you can see really looks like a max or a min. Now, I can twist this around a little bit and change the direction slightly to a different form of the word, and it changes the answer. So for problem number 6, I'd like to find the local maxima. Is that right? Yeah. And minima. Seems like a similar word, right? But it's not. It means something really different. A local maxima or minima is the highest point on the graph and the lowest point on the graph, and it might not even be a max or a min on the graph. No, not necessarily. You look for the highest y value in your problem and the lowest y value in your problem, and sometimes that might be a max or a min on your problem, and sometimes that might be an endpoint. So in this problem, I'm looking for what's the highest point. 2, 10. Does everybody agree? All right. So that's my highest point in my whole problem. So the maximum value, the maxima is 10. It's not the actual point, it's the value of the y in that point. And the minima, what's the lowest point? -8, -4. So the minima is -4. So when I talk about my minima and my maximum, I'm really only talking about the y value. What's the lowest y, what's the highest y. That's all I'm doing. But I've got to find those 2 points. And they're not always maximum and minimums on the graph. So to prove that to you, I'm going to draw one other graph up, and I'll make sure that the answers to these 2 questions might not be one of the maximum minimum points that you listed. All right. And I won't make this one as big a graph, just so that we can have a few points to look at. Now, I could go through every piece again that we just went through, but I think it's more important that I focus on that maxima and minima, and not spend a tremendous amount of time listing things you already know how to do, like x-intercepts and y-intercepts and all that. But can everybody see that there's a constant piece in this one? And what interval is that constant on? 2 to... How long is it? From 2 to what? 3. Even if I don't put a dot there, it ends there, right? So this would be your constant part from 2 to 3. So there's an example of constant in your notes without having to go through and do the increase and decrease again. All right, so let's talk about that local maxima and minimum. Again, it's the y value that's at the highest. Now, I have lots of maximum minimum points, right? This is a minimum, this is a maximum, this is a minimum. But not all of those may be the maxima or the minima. What is the highest y value on your graph? 2. This point here has it, and this constant part over here has 2. That is definitely does not look like a maximum and a minimum. Would everybody agree? But it is the value of the maxima. What is the lowest point on your graph's y value? That actually is a minimum, isn't it? But in this particular case, it is the lowest value on the graph. Now,
what would you put for like your fifth step if you're on the maximum minimum? Would your maximum be?
This would be your minimum at real minimums and maximum points would be at -3, -2, and 0, -3, and then your maximum would be at -1, 0. And that'd be the only maximum. But when you talk about maxima and minima, it's the absolutely only point that's at the highest and lowest point on your graph. So that's a big difference in vocabulary. And this vocabulary is very important. And then when you get to calculus, we change it up just slightly. Instead of calling it local maxima or local minima, we call it absolute, which makes sense because it's the only value that's at the highest and lowest point. All right, now that's the first part of today's lesson. The second part of today's lesson that I want to focus a little bit more in depth on is the even odd thought. Because we only had one example, and both of these are neither, right? Okay, so I'm going to focus just a minute on is it even, is it odd, or is it neither? So go back and think about what we studied with symmetry, and this will help you. Because this, to be even, you have to be on both sides of the y-axis like a parabola, right? And to be odd, it has to be like that cubic function that we've been discussing so many times going through the origin that looks like I rotated around 180 degrees. Now, if it's not something like that, it's going to be neither. So that symmetry of y-axis, or that rotating around for the origin symmetry, is what gives away if it's an even or odd function. Now, look like an M? What do you think? Even, odd, or neither? It's even. Because in this problem, if you cut the y-axis in half, it would fold on top of each other, assuming that it kind of doesn't look the same size on both sides, but assume it is. Because sometimes it's hard to hand draw that. But I wanted it to look like an M so they could fold over on top of each other and make it even. That's a neither. That actually is a logarithm graph. And logarithm graphs do not have symmetry. So it's a neither. And the reason they don't have symmetry is because they have a vertical asymptote that draws right there that they can't cross over. It's kind of hard to have symmetry. Because if it was going to have something, it'd have to flip over that line. And it can't do that. And then why does it have origin? What did you see me do to make it? I rotated it 180 degrees. That's what you need to do in your brain when you're looking at it. I can't either. That's why I went back and did that. So the key here is, that's a really easy concept, right? It's not difficult to look at and figure that out. All right.
We do need to go through all the steps that we did earlier
Mm-hmm.
on each one.
Mm-hmm. All right. So to limit your homework on this lesson, there are 2 more pages to go with this that I haven't got to yet. But you have 8 graphs to do it all. X-intercepts, Y-intercepts, intervals of increase and decrease and constant. Is it even, odd, or neither? List the maximums and minimum vertexes, and list me the maxima and the minima of the whole entire problem. Just 8. And it's in Canvas.
Okay.
Because y'all still have to finish the other assignment, right?
Can I just go ahead and let us start on it?
Yeah.
Start now?
Yeah, you can go ahead and start. Yeah, y'all got about 15 minutes. Y'all can get a little bit knocked out. I don't care which one you start on. You decide if you want to finish the homework from last night or if you want to start the new homework because you think you can get more of it done. I don't care.
Yeah.